All right, in this video, we are going to work the following problem. It says, write a recursive method that computes the nth Fibonacci number. All right, so the Fibonacci numbers are a sequence of numbers like this. And then how it works is that you start kind of with the first two, 0 and 1. And then to get the next one, then you would add the previous two together. So 0 plus 1 is 1. And then to get the next one, right, it's 1 plus 1 is 2. And then to get the next one, it would be 1 plus 2 is 3. The next one would be 2 plus 3 is 5. And the next one would be 3 plus 5 equals 8. Okay? And so on and so forth. All right, and you can see those are the numbers that we're generating here. So to calculate a Fibonacci number, right, say like this 8, what you need to know is the 2 that come before it. Okay? So that is the key observation here. So just like in the factorial problem, right, we are going to base our calculation off some previous values that we had here. In the factorial, it was just the previous one, right, we looked at. But in this one for the Fibonacci numbers, we're going to have to know the previous 2 in order to be able to compute the next one. All right. So going to JGrasp and shuffle some things around here. Okay, so I'm going to put the class header in here, Fibonacci, and then main method header, and then our method that we're supposed to be writing. All right. And so the input for this method, right, we want it to be able to calculate the nth Fibonacci number, right? So if we put in, I guess this would be the 0th one, we get 0. If we put in 1 as an input to this method, we should get 1. If we put 2, we should get 1. If we put 3, we should get 2, and so on and so forth. Okay. So we need as a parameter an int. Okay, and we're going to return an int out of here as well, the nth Fibonacci number. All right, so let's start with the base case, and the base case is if we want the 0th Fibonacci number, right? We know that the 0th Fibonacci number is 0 itself, okay? So we will return 0. All right, and then for the next one, right, the next Fibonacci number 1, right, what we said was the key observation back when we were talking about this was that if you know the previous 2 in the sequence, right, then it's really easy to calculate the next one because you just add the previous 2. But right here, the first one, there's only one previous one, right? So in this problem, you can't apply that logic to that you can for all the rest of these. There have to be at least 2 that come before it in order to do that. So here, what we'll need to do is just go ahead and add a second base case. Okay, so if n equals 1, then we will return 1, right? Because that is the next number, right, in the Fibonacci sequence, this number right here. Okay. Here we use the else if, right, so that at most one of these gets executed. All right, and now we are ready for the case for all the rest of these, right? for every other one in the sequence, every other number in the sequence, what we are going to do, right, is just add the two that come before, right? So okay, so we're going to add the two previous ones. Well, what we would do, right, to add the two previous ones is we are going to call this method again. Okay, so we are going to call Fibonacci, the Fibonacci method again. Right, so adding this in there, right, is one of the requirements for a recursive function. This function calls itself. Okay. The other, right, the second one was that we have a base case, and we actually have two here. Okay. And so now what we want to do is call the Fibonacci number. What we need are the two previous ones. So if the current one, the one that we're looking to calculate, is n, right, the one that comes before it would be n minus 1. All right, so that is the one that comes immediately before the one that we're going to calculate. And we're going to add the other one. So here we're actually going to have called this function twice, right? For recursion, you just need the function to call itself at least once, right? And so it doesn't say you can't call it many times, and that's what we're doing. We're calling it twice here. So what we need to calculate the nth Fibonacci number is the one that comes before it, and position n minus 1, and then the one that comes before that would be n minus 1, which you can write more simply as n minus 2. Okay. So this is the one that comes before the nth. This is the one that comes before that one. We're going to figure those out and add those two together. Okay. All right. So let's test that out and make sure everything is going okay here. So to test it out, let's try a couple of the base cases. I'm just going to print them out so we can see. Actually, you guys know about loops, right? So we can let's just test this out using a loop. So for int I equals 0, I less than, let's say 10, I plus plus. All right, and I'm just going to use print f. And just keep a space in between those. And here I'm going to call the Fibonacci method and with I here. So I am just creating a loop to print out the first 10 Fibonacci numbers. All right, let's do that. All right, and there you can see, right, we are getting the Fibonacci numbers, the first 10 of those. All right. All right, so again, what I want to do is kind of work my way through a method call here, just to make sure that you understand how this goes, right? And I think it's important so that you can kind of see how this works. Okay, so let's do that. And on this one, let's just let's go with 0. Let's just do 3. All right. Because that's still going to take a little bit. All right. I'm just going to shorten it as Fibonacci, right? All right. So we're going to call Fibonacci 3, right? And so what happens, right, is it's going to come in here. This is going to be the value of 3, right? And we're going to get if n equals 3. It's not, right? Or 3 equals 0, right? It's not. Then it's going to jump down and say if 3 is equal to 1, right? It's not. So that's false, right? This one's false. And then it's going to drop into the else, right? All right, in the else, we do return Fibonacci n minus 1 plus Fibonacci n minus 2. So we return Fibonacci of n minus 1. In this case, n is 3, right? So that would be Fibonacci 2 plus Fibonacci 1. Okay. So these two method calls are going to get executed, right? And so up here we'll have Fibonacci 2. And then also we will have Fibonacci 1. All right, so tracing through Fibonacci 2, right? That's going to say if 2 is 0, which it's not, right? If 2 is 1, it's not, right? Else return. All right, and then Fibonacci 1 plus Fibonacci 0. Okay. So that would all get done there. And so, all right, that would actually spawn another Fibonacci 1, right? But there's, since we're kind of doing this by hand, we'll just kind of do it once here, right? And then put it back in the spots that we need it. All right, so then Fibonacci 1 would get called. So when we do that, we would get if 1 equals 0, which is false, right? And then if 1 equals 1, that's true, right? And so therefore we would return 1, right, in that case. All right, so that 1 would get sent back to here. Okay. All right, and so then, right, Fibonacci 1 would get called again, right, over here when it's calculating it. And so Fibonacci 1, again, right, is going to, I'm not going to, again, it would issue another method call, but I'm not going to trace it again, right? That 1 would also kind of go back here. As well. And that 1 kind of looks like a 2, so let me rewrite it. All right, and then we still have this method call that would have to get done, right? Fibonacci 0. When I do that one, I would get if 0 equals 0. It does equal 0, right? So I would return 0. Or sorry, yeah, actually it is 0. Okay. All right, and so then that would get returned, right, and go here. All right, so Java would evaluate this statement and go, okay, that's a 1, that's a 0, right? So this comes out to be a 1 altogether, right? And then that 1, right, would get returned all the way back over to here. Oops, jumping ahead of myself. All right, so Fibonacci 2 would return this 1. That 1 gets sent back over here. right? And then that gets evaluated, and then finally this returns a 2, right? So in this case, in the previous case when we were talking about this situation with the factorial, right? It was kind of we went down a bunch of method calls, right, until they bottomed out. But it was basically just one right after the other till it reached the base case, and then it passed the numbers back up. Here we actually have 2 method calls. So we have 2 sort of separate branches of method calls that are all going to bottom out to a base case. And you can see sometimes they'll bottom out to different base cases in this particular one, but then they'll pass back up their values all the way back up again to that top function here. And so we get 2. And that is, right, this is 0, this is 1, this is the second, and this is the third Fibonacci number. So that is correct, right? We get the 2 on that one. All right, and that is it on this particular example.